In this clip, we're going to prove the quick lemma that if we've got a self-adjoint operator and then we have a quadratic polynomial where the coefficients b and c satisfy this relationship, which you recognize from the quadratic formula, then the corresponding operator polynomial is invertible. And so, like I said, this is a quick lemma that we're going to use as part of the work toward the real spectral theorem. If there's some part of this that you want to take away as a lesson, like a deeper lesson for another day, it's the idea that this is basically a property of numbers that we're working with, and that the inner product allows us to use a result for numbers to get a result for operators. Okay, let's take a look at the proof here. So we're going to take some non-zero vector and then put it in the inner product with our polynomial. So if we have t squared plus bt plus ci all operating on v against v in the inner product, like so, then let's see. So using linearity, we can break this apart into, we've got the t squared v term, and then the bt term, and then the c term. And since we've got a self-adjoint operator here, I can move it over to the other side of the inner product, and then we can rewrite this as norm squared tv squared plus b tvv plus c times norm v squared. And now let's see. So since, let's do a little side calculation here. Since we know from Cauchy-Schwarz that the inner product of u and v with any sign in front of it is less than or equal to norm of u times norm of v, then we know that uv is greater than or equal to minus norm u norm v. And so then we can upper estimate this by moving downward. So this is going to be norm squared tv minus magnitude b tv v, and then we still have that v norm squared term at the end. And so now we can basically complete the square here. So we've got tv minus magnitude b norm v over 2 quantity squared plus c minus b squared over 4 times magnitude v squared. Okay, and so notice that at this point, even though it looks like operators and vectors, all these things are numbers because everything's got a norm applied to it, right? So this is just some inequality of numbers at this point, and in particular, these are all non-negative numbers because we've got the square here and the square here, and then the only thing to be checked is that this one here is non-negative, but it's given to be strictly positive by our hypothesis. So that tells us that since we also took v to be a non-zero vector, then this one's strictly positive by hypothesis. So the whole darn thing is strictly positive. Okay, so the upshot is that then if we do t squared plus bt plus ci and we apply it to a non-zero v, then this cannot be 0 So it's injective. And then since it's an operator, that means it's invertible.